Alright, so this is an introduction to A-star pathfinding in Unity. Today we'll be looking at A-star. I'd like to make this a series of videos as I think it'll help me learn and hopefully others too. There'll be some links in the description below on A-star and the documentation. So pathfinding A-star asset is pretty expensive. It's $100. But it's years of computer science, mathematics, and Unity component wrapped into one. If you're building anything and you're serious about completing it and you need pathfinding, this will save an incredible amount of time. Before we look into the demo, let's just get a little bit of background. Pathfinding in general can be broken into about 4 pieces: a starting point, a target, an obstacle, and a path. It's represented in a graph data structure where the data in the graph are called nodes and vertices, and the connections are connected by what are called edges. There'll be some more links around this if you want to learn more about graphs. There are 3 major pathfinding algorithms. There's a breadth-first search, Dijkstra's algorithm, and A-star. Let's look at Dijkstra's and a breadth-first search. Dijkstra's has quite a bit of pros. It can weight terrain. It will find all the paths, and it will determine the shortest path. It's also the most expensive, as you can see the blue over here, and how much it needs to traverse to find the path. Greedy best search is a breadth first search. It will traverse less than Dijkstra's, but it will not always find the shortest path. A-star combines the best of both of these worlds, where it will find the shortest path and traverse the least. So let's look at that demo. Okay, let's get right into it. Right now I'm using Pro Builder with 5 meters set. And then let's name it floor and set it to 0, 0, 0. Okay, next we're going to create a grid object, set it to 0, 0, 0, a start object, and a target object. We're going to make sure that we have an obstacle and agent layer, and we're going to set those start and target to agents. Next we're going to go to the grid and we're going to add the Pathfinder component. We're going to set it to a graph type, and we're going to set the width and the depth. You got to play around with it. Right now the node size of my grid is 5, so you can keep playing with the width and the depth until it is symmetrical. Then you want to go to the obstacle layer mask and make sure you've selected obstacles and the mask under the height testing, and uncheck obstacle and agents. This will just ensure that your agents aren't part of the terrain of the grid and that your obstacles create negative space on the grid. So now we're just going to ensure that our start and our targets are zeroed out, and we'll create geometry as children inside of them. We'll set the Y to 1 so they're not inside the grid. And we'll set the target sphere further down on the grid to make a more interesting path. Next, we'll set the AI destination setter and set the target, and an AI path component, and set the max speed to 10. If we run it, you'll notice that our geometry kind of skips over the corners, which isn't intended. So how do we fix that? Well, we add some obstacles, and we'll set the obstacles with their layers. And we'll have to play with the grid again to rescan. Now I'm setting the node size to 1. The width and the height to 100. I'll rescan and set the diameter of the obstacles to 2. You'll see now there's adequate space, and our starting cube is taking the A-star path.